Hello, everyone. In this lesson, we will build on the foundation of the previous lesson to program and debug the robot handling workstation. Let's follow the video to see how to program and debug the robot at the actual workstation. Before programming, let's demonstrate the methods and steps for configuring UI, UO, DI, and DO signals. First, enter menu and select I/O. Let's first look at the configuration process for DI and DO. Select Digital. And after entering the digital interface, choose the F2 menu. There corresponds an allocation option. Now, let's allocate for DO first. Select F2. And we see this option. The signal we need to configure is DO120. We see it in the 6th row of this signal configuration. According to the configuration interface information provided earlier, configure it accordingly. When this configuration takes effect, the status bar will display an active state, indicating that our configuration has been successful. For specific configuration methods and steps, refer to the previously discussed signal configuration methods and steps. Next, let's look at the DI signal. When we select F3 to switch to the DI signal, we see that the 7th row on the teaching pendant will display the configuration information for DI120. Specifically, this is the entire configuration information on the teaching pendant, configured in accordance with our originally designed configuration interface. Next, let's look at the process of configuring UI/UO. We also select Menu, choose I/O, then select the UOP option and enter. Similarly, here we can use the F3 key to switch between input and output port signals. When we need to configure UI/UO signals, we select Allocate F2. The specific configuration information is here. This is the configuration for UO. Here we have configured the 7 signal points from UO1 to UO7. For specific details, refer to the interface. The methods and steps are as previously discussed. Switching to UI, we select to view a configuration signal. This way, according to our design, we have completed the configuration of DI, DO, UI, and UO signals following the process. The status bar showing active confirms that the configuration has taken effect. Next, we can enter the program debugging state and create a program named SR0005. The specific method steps are as follows. Select the Select menu. Choose Create. Select F1. Then enter 0005 and click OK. This way, we have created the program. After creating the program, we select F3 for Edit, so that we can program the RSR0005 program. The specific programming methods and steps are as follows. After entering the RSR0005 program, we can follow the programming instructions learned previously, according to industrial requirements, to complete the programming of this control requirement. A specific sample program is as follows. After completing the program input, we use manual debugging methods to debug the robot. When the conveyor belt sensor detects material, the robot starts to grab the material from the conveyor belt and places the first piece of material at the designated workstation position. When the second piece of material arrives at the conveyor belt position, the robot grabs it and stores it as required. When the third piece of material arrives at the conveyor belt position, the robot grabs it and then completes the grabbing and storing of 3 pieces of material. The entire program debugging is finished. Safely follow industrial requirements to meet control demands. After completing manual programming and debugging of the robot, next, we need to switch the robot to automatic operation mode in RSR mode. Let's demonstrate the specific methods and steps. First, select Menu. Then choose 0 to switch to the next interface, select System. And then choose Configuration to enter the configuration menu item. First, we need to set the 7th option, which is the dedicated external signal option, to enable. The method to enable it is to press F4 to activate it. Next, while holding down the Shift key and the down arrow key to switch interfaces. At line 43, we must select F4 to configure it as the remote option. After configuring this option, we continue to select the menu key to switch to the settings menu item. Then enter the main menu. Select Program and go into Select Program. Here, by selecting the F4 key, we choose the RSR mode and click OK. Next, select F3. In the design process, we named the program we just wrote as RSR0005. As we already know from the introduction to the RSR operating mode earlier, we need to set the base number to 0. We use UIE to call the RSR0005 program. How do we do that? We need to configure the RSS0005 program to be associated with the RSR1 program. Right here. Then select Enable. And set the following number to 5. This way, we can start the program corresponding to the program number of RSR1 through the UI9 input port. Through this configuration, we see that we have associated the RSR1 program number with the corresponding program RSR0005. After setting this up, the configuration on the teaching pendant is complete. Next, we need to prepare some external components. First of all, we need to connect a button to the UI9 signal for controlling the external RSR startup signal. As you can see, we connect this button to terminal 9 on the CRAM15 card, which is the port for the UI9 signal we just configured. When completing the configuration of this UI9 signal, we must ensure that during automatic operation mode, UI1, UI3, UI5, and UI8 should be connected according to normal safety standards. The corresponding sensor signals and switch signals should be connected properly to ensure these ports are in an on state to meet the conditions for automatic operation. After connecting this button, next, we need to switch the mode on the teaching pendant to the on state, which means the switch is turned on. Next, we need to set the robot control cabinet button to automatic operation mode, which is the auto state, and then turn the knob to the leftmost position. Next, we need to ensure that the entire robot system's safety systems are in normal condition, including various emergency stop switches, safety protective light curtains, and safety doors being in normal states. As we see now, the safety door is not closed, which does not meet the starting conditions for automatic operation. We need to close the door. After closing the safety door, next, we need to check if there are any alarm messages on the teaching pendant. If there are, we need to clear the alarm before switching to the running state. Next, let's check if there are any alarm messages on the teaching pendant. Upon checking the alarm message column, we find that there is still an alarm message present. This is because a normal alarm message is generated when we switch the toggle from manual mode to automatic operation mode. We only need to press the reset button on the teaching pendant to clear this alarm message. After clearing the alarm message, we just need to press the switch connected to UI9 to start the automatic operation of the RSR0005 program. After pressing it, the program enters automatic operation mode and follows our industrial requirements, first grabbing the first piece of material. Then after completing the grabbing of the first piece, immediately grabbing the second piece, and placing it in the designated position. Next, grab the third piece of material. And place it in the designated position. The entire control process is completed, finishing the automatic operation debugging of the program. By watching the video, we have completed the overall debugging of the robot handling workstation. The handling workstation is a typical application in robotics. Through systematic learning, we have mastered the composition and design principles of the handling workstation and have grasped the methods and steps for debugging, laying the foundation for us to be competent in robot-related work in the future.